Welcome to the second part of this introductory course on Real Flow in Cinema 4D. So let's begin by introducing the interface, the plugin, and then we'll look into the details. So we're going to do a brief introduction. In the first lesson, we were talking about the software itself, and in this lesson, we'll be talking about the interface. So first, open up Cinema 4D. And then the Real Flow menu should appear in the menu at the top. Okay, here should appear Real Flow. What we are going to do now is undock the panel. Okay, and then we are going to dock it here. Perfect. In order to get Real Flow running, we need to create a scene. On the right, you'll find the scene settings where we can adjust the name, layers, if we want to make it visible or not. But don't worry because we'll have a look at them later. But these are common features and panels of Cinema 4D. So we have here the coordinates panel, the solver panel, which is very important. Why? Well, because if we check this option, okay, and select a device, in my case GTX 1070, the simulation will run faster. For the moment, let's deactivate it. Another panel is the cache, which is also relevant for simulation because it allows us to see them clearer and work with them more comfortably. But I'll explain it afterward. Then we find as well the display panel, where we can decide if we want the scene to be visible or not. Okay? For example, if we click here, it's invisible, okay? Here in the panel at the top, we find the meters, which are the points of particle creation. For example, here I've selected one of them, and if I press play, the fluid simulation begins automatically, see? The particle simulation starts, and the amount of particles will depend on the number of frames. Higher values will generate more particles per frame. The number of frames was set at 90, but after increasing it to 150, the animation will last longer, up to 150 frames. Is it right? So, as you can see, there are different types of emitters. We'll go deeply into them later. After selecting an emitter, the new emitter is automatically added to the scene tree inside the emitter group. It also happens with the scene. When we click on it, the different elements contained in it are organized, which are measures, emitters, fluids, and demons. And what are demons? Demons are used to introduce forces for accelerating and influencing the particles, creating different effects as a result, okay? For example, the gravity demon, which adds gravity to the scene. Guys, this is very important. Let's see why. If we go to the emitter and rotate it without gravity, obviously, particles flow out upwards. See? There is no gravity. But after activating it, okay, the fluid emits out downwards automatically. Something similar happens with physics in Cinema 4D or any other 3D software. It's easily understandable, okay? So demons are great for adding effects and property to the scene. But we'll see it later on. Next to the demons, we find rigid and elastic parameters, which basically can be used to apply these rigid and elastic properties to a particular object. When do we use it? Okay, let's assume we have a statue and we want it to fall apart. Thus, we need to apply the most suitable property for this case, which is the rigid. On the contrary, if we want to apply a jelly-like aspect, then we'd use the other one. Then we find the fluid option, and here in this panel we'll be able to determine the fluid's quality. These parameters cannot be appreciated since the measure is disabled. But what is the measure? Well, meshing turns a particle cloud, it is the fluid, into a solid polygon object. It is a visible surface. I clicked on render, but I cannot see anything, so I activated a physical sky. Why is that? Because this is a preview. So, apply gravity to the object, and in order to see the final result of the fluid, we need to apply a measure, okay, to see it. Click on it, and it will be automatically included in the scene tree. And now we can see the simulation, see? Awesome. Guys, we can modify the fluid's quality from both the measure panel and from the fluid panel. We can decide if we want it more or less jelly-like, elastic, and so on. Overall, these are the basics of RealFlow. We have the main panel, as I said, which is the scene. After creating a scene, a tree is automatically generated in the panel on the right. From here, we're going to start working by creating an emitter, any of them. We can also decide which daemon to apply, like, I don't know, gravity or attractor, for example, which attracts particles towards a surface. Then we would add a measure to make this liquid visible, like that. The next step will be tweaking the fluid and the measure's properties. Depending on the result we want to get, we'll apply a different number of daemons and modify certain parameters. For instance, if we go to the scene and click on the Cache tab, we can cache a simulation in order to work with it easily. Have a look at this scene, which is quite simple. Here we see a liquid attracted by an attractor daemon. So, if we want to write the simulation data to disk, then go to Cache Simulation and a progress bar appears. Once the simulation is finished, we can move the timeline to a specific keyframe to see the results and appreciate the details of the simulation. Okay? If we hadn't cached a simulation, the animation wouldn't be visualized. Press Remove Cache to delete the cache folder's contents, and after deleting it, the animation also disappears. Okay? Okay, so we've lost this animation. Click again on Cache Simulation to save the data again. Obviously, complex scene slow down the simulation process, but using this option is highly advisable, particularly to check the simulation results. In addition, the Solver tab, we can check the Use GPU checkbox, okay? Well, this has been all. In the next video, we'll be having a look at the emitters, so see you there.